All right, so in this video, we're going to see what hydrogen can do as a ligand. And so one thing it can do is make a so-called hydride, which is formally H minus, but can have significant amount of positive character. It kind of depends on how the bonding is done. MO diagram, there's only one electron for hydrogen, it's just an atom. So the only thing that can happen is bonding via sigma donation. So this looks like this. You can make these by adding a strong acid to different organometallic complexes, and then you'll get this hydride here. You can also have dihydrogen act as a ligand, which is kind of interesting. So we know the MO diagram, very simply for dihydrogen, right? We have a sigma bonding and a sigma anti-bonding formed from the two 1s orbitals of each of the hydrogens. And there's two electrons in the sigma bonding, of course. So you can have sigma donation occurring, but you can also have back bonding from the metal into the sigma, as long as it's not too strong, and blow apart the hydrogen molecule. Now, if it is too strong and you're blowing apart the hydrogen molecule, you're going to basically you're going to basically have more of a structure that's like this, right? So, I mean, if you put two electrons into that MO diagram, at that point, that's not a stable molecule, right? I mean, because we know the anti-bonding orbital is always higher in energy than the bonding orbitals. So you can kind of think about these sort of being a continuum of how much back bonding there is. If you don't have any back bonding, maybe draw it like this. If you have a little bit sort of delocalized here like that, and then the extreme case is sort of two hydrides, okay? So that's kind of interesting. And so there's an enzyme hydrogenase that does this sort of chemistry and actually can take hydrogen gas and take it into hydrides and then release that as protons, or take protons and go the other way and make hydrogen gas. And so it can do both of these reactions really efficiently. And there's a lot of different types of these enzymes. So there's some that use iron and nickel, okay, some that use iron and iron, and some that are mononuclear, just use iron. And people are really interested in these, especially when you start thinking about like fuel cell catalysis and hydrogen generation. Could we make like mimics of these that don't have, of course, all of this crazy complicated protein structure, but instead are biomimetic, right? And then can help us make hydrogen in a very efficient way. People are interested in that for this sort of small molecule catalysis for energy applications. So that's just a little bit about how hydrogen and hydride can act as a ligand.